Hello, friends and systems management colleagues around the world. Welcome to the SCOMathon 2021 session, SCOM or Azure Monitor, when to use which. My name is John Joyner. I'm a Microsoft MVP for Cloud and Data Center Management. I work at Accountability, a Microsoft partner that uses the tools SCOM and Azure Monitor that we're going to talk about today to deliver our MSP and MSSP services. A SCOM housekeeping slide. Remember that you can reach me on Slack during the SCOMathon event. I'm a huge coffee drinker, so you'll probably find me in the SCOM Cafe as well. Thank you, Squared Up and Cookdown, for asking me to speak and letting me speak on this topic, and thanks for hosting this community event. Our agenda today will start out with a Microsoft monitoring landscape and roadmap review, and we'll take a look at where Microsoft positions the two products. And then we're going to look at a very specific scenario, replacing SCOM with Azure Monitor for Core OS availability and performance monitoring. And we'll describe very specifically what that means. I'll give you some tools and tips that will be helpful in a migration scenario, or if you'll be adopting Azure Monitor as a primary monitoring tool. After some demos, we will take a look at a thought-provoking list, hopefully, of the strengths of the two products in various categories. We're looking at the alert views of the two products. I can let you know that both Azure Monitor and SCOM are great at producing alerts, as many as you want. How the alerts get produced is very different, and that's at the essence of how and why the products have different roles and features. SCOM is a traditional IT database-based product in that the monitoring data is stored in a database, and then user interface or API queries the database for the state of the objects. This is very much like the first monitoring tool that I worked with in my career, which was HP OpenView on HPUX, which had an Oracle database. I remember it was difficult to keep the database healthy back in those days. Modern SCOM admins will probably agree that at scale and over time, the SCOM SQL database becomes more difficult to keep healthy. And of course, other products like Orion SolarWinds are also a database-based product. In the Orion case, there are polling engines that provide that write to the database, which is then read by the UI. Essentially, Azure Monitor works indirectly on the monitored servers by using a copy of their log and performance data that has been streamed to a repository, rather than monitoring directly with workflows on the monitored device, much like SCOM does. Azure Monitor's roots are similar to those in the open source stack known as ELK, Elasticsearch, Logstash, Kibana. Those open source apps collect, search, and interpret monitoring data. Data is streamed to a data lake, and the monitoring occurs by searching the data lake with queries. That's how Splunk works. That's how Log Analytics works. The popular Splunk product functions in the same way. Splunk Cloud is very similar to Azure Monitor as a solution. Grafana is a popular visualization tool that can be swapped out with Kibana in the ELK stack, used with Splunk or even with Azure Monitor. So Azure Monitor plays in a more open field of monitoring tools than SCOM, which was a more closed, proprietary, monolithic type of monitoring platform. We'll see that in these next two slides. We're taking a look at what Microsoft itself says are the primary missions and placement of these products. If we want to know where the products are going, let's see what Microsoft tells us. Today, if you go to Microsoft.com, Microsoft will show you this picture in the current technical white paper that has a monolithic SCOM monitoring agent in the center, which is doing monitoring both in Azure and on-prem. But the monitoring is happening mainly from that on-prem environment, focused on the VMware or the Hyper-V data center fabric, right? Look at Microsoft's monitoring. Their slogan for SCOM is best of breed Windows monitoring with robust cross-platform support. So SCOM is focused on that private cloud fabric and on the monitoring of servers, right? It's a private cloud, hybrid cloud management offering focused on being delivered from the private cloud. We're going to now contrast that with Microsoft positioning of Azure Monitor. Look, it's not a monolithic solution. It is a set of microservices, modular, much like the Elk stack, with various interchangeable components. For example, see the second tier, the visualize tier. That's where, for example, Grafana can also perform a role, as well as Azure Workbooks, Power BI, and other user experiences. So Azure Monitor very squarely placed in the public cloud and hybrid cloud environment, with the management coming from the public cloud. So Microsoft positions SCOM and Azure Monitor differently, right? I'm going to jump right away into a cost comparison slide. It's been my observation that something holding shops back from moving to Azure Monitor is uncertainty or doubt about the cost. So I did some work here to share with y'all. In the center column of this slide, where it says System Center, these costs are driven by Microsoft licensing. System Center is primarily licensed for your on-premise private cloud environment and is focused on the physical server and the number of cores in that server. The most expensive way to employ System Center is on a single physical server, which you can see would be a $55 per month cost, as calculated as it describes. It's using the 2-year open with SA. So at that, using that SKU, which is basically the Windows Server System Center standard SKU, it's very expensive, $55 for one server. But look at if we run System Center on a densely populated virtualization host, for example, with 32 guests, that cost goes down to $5 per server. So the more servers, the more servers that you're running on a single host, the more virtual machines on a single physical host, the cheaper System Center becomes. Azure Monitor in the right-hand column is not is variable. It is it is certainly variable, driven by what you're monitoring. And so that $10 cost that you see in the upper right-hand corner, that is what we calculated that the monitors that I'm going to show you, the SCOM equivalent OS monitors, the 15 specific monitors that we're going to cover in this solution, they have been calculated to cost about $10 a month per server on average. Your domain controllers will have more logs. Your non-domain controllers will have less logs. They average out. And the actual cost can vary between $5 a month and $13 a month per server. You have a lot of control over that by what you monitor, what logs, and what performance metrics that you collect. But in this scenario where we're looking at parity between Azure Monitor and SCOM, my best calculations are that $10 a month per server is a fairly safe number for that consumption. For your non-Azure servers, we add $6 a month. That would be your Azure automation guest configuration service charge. We consider that very important for the Azure Monitor role because Azure automation change detection is how we detect stopped services. Like that's how we know that a service that was running 15 minutes ago is not running anymore. We need to alert on that, right? And we need the Azure automation change detection service to do that, which is free for servers in Azure, but is $6 a month for servers not in Azure. So we come up with this rule of thumb of $10 per server for Azure Monitor, and then $16 a month if it is an Azure Arc server, if it is not running in Azure, to pay for the consumption of the monitoring costs and the Azure automation costs. So that's where the $10 and the $16 comes from in the Azure Monitor column. The System Center column, as I said, is driven by the density of your virtualization host. So there's a break-even point, right? Between somewhere between 8 and 32 guests, SCOM will become less expensive than Azure Monitor. So go forth with the knowledge, that Azure Monitor has a cost that is comparable to SCOM and can be less expensive than SCOM or more expensive than SCOM, depending on what you're monitoring and the environment. So the cost is not the only driver. It's a big driver, but not the only driver. So if you're a shop running SCOM, like most of you that are attending to this seminar, there is no hurry to migrate off SCOM, because if you are internet disconnected, if you have a highly dense private cloud, if you have a heavy SCOM investment, you don't need to worry about Microsoft pulling support for your investment. SCOM is full first-class Microsoft citizen through in the Windows Server 2022 product era, and with Microsoft lifecycle support of about 10 years after GA, through the end of this decade, you're going to have robust SCOM support from Microsoft. But if you're not in one of those categories, if you're just using SCOM for core monitoring, if you're underutilizing SCOM, if you're just using it mainly for up-down detection or basic server core OS monitoring, if you're moving a lot of servers to Azure, if you're already on a journey to move as much of your infrastructure into Azure as possible, if you're deploying Azure Sentinel as your enterprise SIEM, you're going to be deploying the log analytics agent on all your machines anyway. So you're positioned right away to start using Azure Monitor. Or maybe you want to use Azure Arc solutions like the Azure Automation Update Management solution, which offers essentially low, no-cost, free management of your server updates, something that you might be using SCCM, Microsoft Endpoint Manager for, which is covered under System Center license. And you think, well, how am I going to do my updating if I don't have my System Center license? Well, you'll use the Azure Automation Update Management solution, which is excellent. And so you might want to use, for any of those reasons, Azure Monitor is going to be your destination technology, and it's better to start sooner rather than later. Whichever of these two tracks, the SCOM or the Azure Monitor track, applies to your environment or a portion of your environment, go for it. You don't have to use only one or the other. So the specific scenario that we're going to talk about is replacing SCOM with Azure Monitor for our core OS monitoring. We want to know, can we do it? So we established that financially, economically, business-wise, we can do it. Now, what about can we do it safely? Can we do it confidently? So we want to make our data-driven decisions. On this screen, we're looking at a relatively new feature of Azure Monitor. That's the VM guest health solution, in the lower half of this screen, you can see a hierarchical roll-up monitor for a virtual machine, which is very similar to the view in the top of this slide, which is from, of course, from SCOM. So the SCOM Health Monitor has been a super valuable aspect of SCOM for all these years, and now finally there is a similar feature in Azure Monitor. So if you were waiting for Azure Monitor to have a monitor roll-up feature like SCOM, well, it has it now. So if our objective is to replace SCOM with Azure Monitor for Core OS monitoring, we have all of the instrumentalities to get it done. So how do we make the data-driven decision on what to monitor with Azure Monitor compared to SCOM? I mentioned that my company uses SCOM for our MSP operations, and in fact, we operate a number of shared and dedicated SCOM instances managed on behalf of customers. And so I have a large amount of data to draw from. And across all of our managed SCOM environments, many thousands of servers, I collected data for a 4-month period ending in February of this year. And on this screen are shown all of the alerts, all of the SCOM alerts that we received from the server OS management packs. So the Windows Server OS management packs in our customer environments over that 4-month period. While there may be many more possible alerts, these are the complete set. This is the complete universe of alerts that fired in production, or very large sample and long time period. So this becomes basically our core set of what we're monitoring. In this list, basically the only SCOM alert that occurred during the period that there's no corresponding match for is the total bandwidth over threshold alert from the SCOM. And probably of the metrics of disk, CPU, and memory, network is the least often what brings the server down. The bandwidth utilization is exceeded. So we don't consider that a showstopper, that one monitor doesn't have a direct port into the Azure Monitor solution. If you do have a server scenario where monitoring the network is critical, absolutely that can be added. But in terms of calculating the what alerts and then the cost of running those monitors and alerts, it's not included in this solution. But other than that, we do have 100% coverage in our Azure Monitor rule set of the corresponding alerts that SCOM produced, monitoring a large Windows Server population. So this view right here, this is our Azure Monitor rule set. So this is the product of that data-driven research into what monitors to select. And you can see that there are 12 rules listed here. There are 3 additional rules coming from the VM Health Monitor rollup. So it's a total of 15 discrete things that we're monitoring. And this is actually how some large IT shops have successfully been using tools like Splunk for years to monitor relatively large environments. Is if you know what to look for, you can achieve a high availability of your resources by watching for those tripwires, and we don't need to waste resources monitoring for things that are not actionable. So how we determine the list of SCOM alerts that we need coverage for. Where do we get the content of these Azure Monitor alerts? Of course, we can write them ourselves. There's actually some great resources available to help you to locate and download, import, or copy manually or via template into your environment these rules. I've got on the screen a couple of URLs to GitHub and Microsoft Document Library, and at particularly the Manageability Toolkit URL, the second listed. There are hundreds of Azure Monitor rules that are available for you to examine and import into your environment. And if they work out, they essentially become a permanent part of your monitoring configuration. Just like as a SCOM admin, you probably have a library of favorite management packs. And in the same manner, you're going to have a library of favorite Azure Monitor rules and rule templates. In Azure, in SCOM, these take the form of management packs. In Azure Monitor, they take the form of ARM templates, JSON documents that you can import into your subscription. So we're going to talk about Azure Arc. You've heard me mention it. You may have heard other speakers talk about it. Azure Arc, I consider a technology disruptor and one of the biggest innovations out of Microsoft in a while. The creation of a management platform as a service is a new paradigm in our industry, and delivering at no cost is really we haven't had a resource like this available in our industry. Azure Arc represents a permanent bridge between on-prem and Azure resources, and it allows your on-premise environment to enjoy the economic benefits of hyperscale computing as Microsoft has essentially perfected in the Azure cloud. So even though you are a small shop or a medium shop or a large shop, you're still dwarfed by the scale of the Azure global cloud, yet you can participate in the efficient management technologies that are in use in that cloud. So even though you are a smaller shop, you enjoy tools that operate at the in the most efficient manner that can be architected. And that's going to give you a competitive advantage when the cost of your tools is driven down. Azure Arc allows you to create objects in Azure for your stuff. Right now, we have servers, SQL servers, Kubernetes clusters supported. Notice this screenshot is an Azure Arc all resources view from an Azure portal, and you can see we've got servers, Linux servers, Windows servers. We have SQL servers. We even have Linux SQL servers on premise. All of these are projected as Azure Arc resources, and you can look at Azure Arc as either taking the Azure control plane and pulling it down into your environment, extending the Azure management into your environment, or you can look at it as projecting a copy or a replica of your environment into Azure, and then either way, it's when you manipulate the controls in Azure, they are affecting your machines in Azure and on-prem in the same manner. A couple slides to show you where Microsoft is going with this. Can you tell which of these two views is the Azure VM and which is the Azure Arc computer? If you look closely, you can, but you can see that Microsoft is taking a lot of effort to make the management experience for in Azure VMs and your VMs on-prem or in any other cloud to make it an identical management experience. If it's a computer, it's a computer. That's a healthy attitude. Here's another example. This is the Azure Arc SQL Server. You can see that although on the right-hand side, which is the Azure Arc SQL Server, is more rudimentary interface than on the left, which is an actual Azure SQL Server, you can see that what they have started out with this new offering is they're trying to achieve perfect parity, so that in this example, if the security recommendations for the SQL Server are going to appear in the same tile in the same manner, and that increases your efficiency, and in this in a security scenario, it significantly increases your security posture when you have a uniform presentation of the resources that have equal policies. You want your on-prem SQL servers to be just as secure as your in Azure SQL servers, and this is a way to do it. It's a great technology. Azure Policy is what makes the Azure Arc and Azure in Azure VM management work in a homogeneous way. Those of you familiar with Active Directory group policy can imagine that Azure Policy works in a similar way. We push out standard settings to many computers. And this slide highlights basically the 4 computer populations served by Azure Arc and Azure Policy, which are your on-prem Windows, on-prem Linux, in Azure Windows, in Azure Linux. So all 4 machine populations serviced equally in terms of enforcing the same policy frameworks. This slide shows how that looks in the Azure portal. We're looking at a policy initiative, a very popular one for this solution that we highly recommend, because this one initiative bundles all of the policies needed to get all the agents that you need installed on all 4 types of computers. So whether it's a Linux machine or a Windows machine, whether it's in Azure or whether it's on-prem, this one initiative, when you assign it to your entire subscription or resource group containing all of your machines, it will install all the necessary agents necessary to get those machines into full management. This is a advanced copy of a diagram, actually, from a new book that I'm co-authoring with Azure MVP Steve Buchanan. The name of the book is Introducing Azure Arc from A Press. We hope to have it out this summer. And walking through the diagram, starting with the Azure Lighthouse component on the right, in the lower right-hand side. Azure Lighthouse is a delegated security model for service providers in large organizations. So whether if you are not a service provider or a large organization, then your own organization staff, RBAC, and security model provides access to do things in this model. You can see in the lower center of the diagram, Azure Policy is applying equally to our Azure and our non-Azure machines. And the Azure Policy is telling those machines to do something like deploy Azure Monitor. And that policy is going to tell those machines in what manner to deploy Azure Monitor. And once Azure Monitor is deployed, we can deploy other solutions. Like moving to the left in the diagram, we have the VM Guest Health solution. And then moving up to the far upper right-hand corner, we have the Update Management solution. So solutions install on top of the agents, and the agents are installed by the Azure and Azure Arc components. Something else I wanted to point out on this screen, the Azure Monitor in the center, moving to the upper left, may produce alerts. And just as in SCOM, you alert or override management, right? Creating override management packs to create exceptions to monitoring for specific machines is important to groom and make your SCOM environment manageable. So we have you'll see in the upper left corner of this diagram, alerts can also be suppressed. And that's something that I'll be showing you in the demo, that just as SCOM has a mechanism for overrides, Azure Monitor does as well. When we talk about Azure Policy, if I assign an Azure Policy to an Azure VM or to an Azure Arc computer, and the Azure Policy involves installing an agent, where that will show up and happen is in the extensions area. So on this slide, we're looking at on the left an Azure VM and on the right an Azure Arc computer. And both of the Azure Azure Resource Objects have an extensions blade. And extensions work the same on Azure and non-Azure computers. In Azure, like on the left on the screen, there is a service called the Windows Azure Guest Agent that's automatically installed on all Azure VMs. And then on the right, you can see extension service. That's what's installed when we installed the Azure Arc agent on a computer. And so whether it's in Azure running the Windows Azure Guest Agent or it's on-premise running the extension service, these services enable you to manage the machine through installing, configuring, and removing extensions. So if you notice in the left, the second extension from the bottom is Microsoft Monitoring Agent. And if you look at the Azure Arc computer on the right, the second extension from the top is Microsoft Monitoring Agent. So in those two examples, that's how these two machines were connected to Azure Monitor, was through a policy that says to install the Microsoft Monitoring Agent and connect that machine to a specific log analytics workspace. All that work is done by the extension service. So seeing how that works practically, here's in the top, this is a control panel a view of an Azure Arc computer, and the only thing that we had to install on this machine was the first thing that you see listed in the control panel, Add Remove Programs. It's the Azure Connected Machine Agent. So that's the that is the Microsoft Management Agent and the Dependency Agent, which are part of the current Log Analytics Agent, or that you're familiar with for SCOM. And in the lower view, you see the extensions blade of this same computer. You can see the MMA and the Dependency Agent installed as extensions, and those were done by the Azure Connected Machine Agent. So we didn't have to install the MMA. We didn't have to install the Dependency Agent. The Azure Connected Machine Agent already running on the machine installed the extensions for us, because we deployed a policy that said deploy these extensions. Now, indicated by the red arrows, that's the newer platform, the Azure Management Agent, and the Azure Management Agent installs. I was saying the Azure Management Agent installs completely through the extension service. It doesn't show up in the Add Remove Programs. So this is sort of the future of how Microsoft Management Agents are going to work with Azure, is that you'll have just one thing show up in your control panel, and then everything else is going to happen through the extension service. So I'm going to move to some demos now. I wanted to put on the screen real quickly just two URLs at GitHub. GitHub is the place that is the source for our community source and the Microsoft source for our Azure Monitor artifacts like rules and workbooks. And I wanted to show these. So the first one here is this is the manageability toolkit. This is the motherlode of Azure Monitor example rules to bring down into your environment. And then the other I wanted is this is a GitHub repository of workbooks, and so you can see there are hundreds of workbooks here available on all kinds of services and applications. This is your visualization element of the Azure Monitor solution. So I wanted to show you GitHub. GitHub is your go-to location for the pieces of the solution that we're showing you. You know, you don't download and install a single management pack. This is a more granular, as need. You know, you deploy monitoring as needed at appropriate for the application that's being monitored. And with that, I just wanted to make sure everyone was aware of those GitHub resources, because they're real important in an Azure Monitor world. So let's look at Azure Policy. Okay, Azure Policy is so key to getting work done in the new hybrid Azure Monitor environment. And I wanted to show you how this works and give you a little hands-on. So we're looking at the policy definition view. We're filtered to policies and initiatives that have the word Azure Monitor in them. And you can see there's a built-in initiative with 10 policies named Enable Azure Monitor for VMs. And to save time, I've duplicated that. You know, I just selected that initiative and basically copied it to a new initiative, and I named it Multiple Workspaces. What I'm showing you guys is how to modify the Azure Policy to install the Azure Log Analytics agent, the Microsoft Monitoring Agent, to connect your machines to Azure Monitor. If you're already using SCOM, if you already have the Microsoft Monitoring Agent on your machines because you're running SCOM, when you push this policy that says connect this machine to Azure Monitor, the policy is going to fail safe, and it's going to say this machine is already connected to a Microsoft environment. I'm not going to connect it. So we have to override that feature. I'm going to show you that. So we duplicate the initiative. So now this is the initiative, the copied initiative that has, but we haven't modified it yet. So it still just has the 10 built-in policies. I want to edit the initiative and add a custom policy that I've written. So I'm adding the custom policy to make it. I'm going to search on just custom policies to make it easier to find my custom policy. Here's my custom policy. Again, I just cloned or copied the built-in policy, and I saved it with a new name, and the new name has the word, or has the multiple workspaces in parentheses. So I've now added that. So now you can see there's now 11 policies in this group. Here's the one that I just added. So now I want to remove the one that this copy replaced. So now that we've deleted the built-in policy, leaving only the custom policy that we added to the initiative, we can save the initiative and assign the customized initiative to our subscription or resource group or other set of servers. I wanted to show you the actual customization that is made to this one policy that's so important. It's down here. The line, the name of the line is stop on multiple connections. There it is. So that line is the line in the policy that has to be changed. The default of this policy is stop on multiple connections true, so that if the VM extension installing the log analytics agent sees that the computer is already connected to, for example, your SCOM instance, it would fail safe. It would not install it would not dual home the machine. But if you do in fact want to introduce Azure Monitor to your existing SCOM environment alongside in parallel to SCOM, you're going to need to change this setting to stop on multiple connections true to stop on multiple connections false. So the false is the setting that you want to deploy if you have multiple workspaces in your environment. How the initiative would deploy, I wanted to show you that you can, when you deploy your initiative, you can deploy it to your entire subscription. You can deploy it to a specific resource group, and you can also deploy it to a resource group with exceptions. So in the exclusions area, let's say that we wanted to deploy this only to these two, let's say the host 1 and host 2 servers in this. These are the two servers that we do want the initiative to apply to. So let's say that we're basically sort of conducting a pilot, right? And so we want this initiative to deploy to our entire subscription, but we want to exempt these servers, right? And so we can do that when we do the assignment of the initiative. We can create exceptions, and so that's another nice granular feature to deploying policy. And when you're first doing a pilot with Azure Monitor, that's how I recommend is that you don't deploy this to the entire subscription or resource group, but exclude the servers that are not going to participate in the pilot test. So a couple other things I wanted to show while we have the demo environment up is I wanted to show how overrides work. Overrides are really important for SCOM. You know, in SCOM, we have our override management packs, and we practice good hygiene with segregating our overrides. In Azure Monitor, we apply overrides as well. If we take a look here, you know, we're looking at our alert rules. Here's our list of alert rules and monitors, our carefully curated list of monitors. And we have an action rules area, and this is where the overrides are, okay? You can see here in my environment, I already have a number of overrides. For example, during the daily backup, these machines have a high memory or CPU utilization during the backup, and we want to avoid those expected alerts. So we create overrides, and the overrides take the form of basically a text string that would appear in the name of the alert, and then a text string that matches one or more computers in your environment. So the override consists of a combination of an alert name and a computer name, you know, very much like in SCOM. An override in Azure Monitor is an action rule of the suppression type. When we choose the suppression type, we can see that we can have a scheduled or a recurrence, and we can have a permanent or a temporary suppression. So we have a lot of flexibility to create overrides. How these work quite, you know, let me show you how simply these work. You know, if let's say I was going to make a new action rule, and I just need to know some text in the alert, and I need to know the name of a server. So there, I've now associated an alert text with a server name. Suppression, in this case, let's say that I want it to be a permanent suppression. And I would call this override foo on server 1. I need to save it to a resource group. I could push create, and I've now created a very granular override very quickly. Another kind of override, the other kind of override is for your VM guest health monitor. The new health monitor rollup implements overrides differently. The overrides are just right here on the configuration tab. So if we go to, for example, the CPU configuration tab for this particular server, we can see that by data collection rule in this environment, we are alerting critical at 90 and warning at 80. And let's say that this particular server is really, really busy. And so to reduce false, positives or noise, we're going to increase the thresholds for this busy server. We're going to change them like I just showed you, and I'm push save. And so I've now very quickly implemented a custom and granular override to this particular server. So overrides are easy to accomplish in the Azure Monitor world, both for scheduled alert rules and for the monitors. I mentioned workbooks. Remember, I showed you the GitHub repository of workbooks. Here's a workbook, a custom workbook that I made to showcase some of the Azure Arc capabilities. You know, for example, here I have our Azure Arc computers queried from Azure Resource Graph, and I have the tags listed over here. Those of you familiar with Azure know that managing your resources with tags is a great feature of Azure because we can sort and filter, we can do cost management, and tags are assigned to your Azure Arc servers just like regular other Azure resources. Here we can see the power of Azure managing the Azure VMs, the Linux VMs, the Windows VMs, the on-prem VMs, all in the same context. You know, in this performance and availability diagram, we have all 4 categories of computers: Windows and Linux, on-prem and in Azure, all of their metrics combined. And I say this is a custom-made workbook that did not take me much effort to build. And this is an example of the sort of custom visualizations that you can make with this solution. So that wraps up the demo items I wanted to show you. And now let's finish up with the discussion of the unique features of each platform. And on the left in this slide is the familiar SCOM overview page, and on the right is the overview page of the Azure Monitor alerts. So that both products producing alerts on an overview page, but completely different engines underneath. This is a chart that I made. It distinguishes each platform's capabilities across 8 dimensions. These are just my thoughts. These are not official and don't represent any official Microsoft strategy. Starting at the top, we have a dimension of how do we define the product? SCOM is a standalone product that doesn't need the internet, whereas Azure Monitor is an assembly of microservices that does require the internet. SCOM requires all the infrastructure that you need for SCOM services, a SQL server, management servers, gateway servers, whereas Azure Monitor is cloud-based and you just drop in. There's no requirement to install any on-premises infrastructure other than the agents on the monitored servers themselves. SCOM works great as a top-level console because the SCOM console is optimized for large volume processing, whereas Azure Monitor, in my opinion, works best with ITSM and SIEM tools, where your Azure Monitor is providing inputs and alert stream to another system. Both SCOM and Azure Monitor have scaling units of different types. SCOM management groups have certain scaling limitations, and although Azure doesn't have scaling limitations, there are limitations on how many Azure Arc servers can be in a resource group. So you have to pay attention to scaling with either product just across different dimensions. SCOM, as you're aware, updates via a rather big upgrade and update rollup paradigm, whereas Azure updates are continuously arriving, and your Microsoft monitoring agent upgrades are going to happen as part of Windows Update, or you can push them through extensions. SCOM has a custom distributed application authoring experience that's really excellent. Azure Monitor doesn't have a custom distributed app experience like that, but Azure Monitor does have network mapping, service mapping, which is extremely useful. SCOM has a service provider model that is based on certificates. Azure Monitor has a service provider model based on the Azure Lighthouse paradigm, which is a delegation of the Azure Resource Manager security model. And lastly, just both Azure Monitor and SCOM have significant ecosystems. They're just of completely different types. The Azure Monitor ecosystem in particular more resembles the open source ecosystem with emphasis on GitHub repositories. So I want to thank you for spending your time with me covering the topic of SCOM or Azure Monitor, when to use which. I hope you feel comfortable in knowing that wherever your organization is in the private, hybrid, or public cloud spectrum, that Microsoft is taking the monitoring discipline seriously and has some great and compelling products for us to get the job done. If you are a SCOM shop, you can proceed with your eyes more wide open on the actual strengths, weaknesses, costs, economies of using Azure Monitor for some or all of your IT monitoring. On my screen is my Twitter handle. I welcome DMs for information about my company, accountability. Our website is accountabilityit.com. And I will be seeing you in the Slack or Zoom areas here at the SCOMathon next. Have a good day.